So today is MABA's fourth webinar of 2024, the Biosolids and Use Success Stories. And my name is Juliana Menta, and I am today's moderator. I'm a member of the programming committee. Let me know if you ever lose audio or video by messaging in the chat, I think. Before we begin our formal session, I'm happy to welcome Mary Baker on behalf of the MABA PFAS Focus Group to provide an update about the group and some of the valuable information they are working on to share with MABA members and the Biosolids community about this important topic. Welcome, Mary.
Thank you, Julie. Yes, so I am representing the MABA PFAS focus group here today, just to give a quick introduction of the group if you're not familiar with it. It was a group created by MABA to help our members and folks in the biosolids community in the region to deal with this tricky, difficult topic. I'll share my screen with you. And here I have a browser. So from our homepage, the MABA homepage, you'll see how can we help you today. If you click on the learn more about PFAS, it will take you to the main PFAS webpage on our website. Here there is some basic information. It also includes the MABA PFAS position statement, as well as a previous press release and some other important documents. And another really great aspect to this that we have available is right here in these links below. And each one of those represents a category of information that we have gathered. And we're always looking for more information if you have it to provide. Going through to one of those links to show you that there is research and information and presentations there. So we have PFAS and biosolids. We also have thermal treatment of PFAS. You can see that there are several different areas of information that we have available. And another important area that we have been working on is the collection of PFAS analysis data and testing results in the MABA region. And we are requesting that from our members and folks in the region so that we can get a comprehensive picture of what that looks like in our community. And so these are graphs that represent the data that we've received so far when being put together. We do guarantee anonymity of that information. There is a letter here linked, and we can certainly customize it if you'd like that, if that helps your group to share this information. There's also an opt-in form if your group is interested in participating in new research opportunities or learning more about new research opportunities as they become available. And we are always looking for interested individuals to join our task force. So please feel free to reach out to me if you are interested in learning more.
Thanks, Mary. All right, so we have 3 presentations during our webinar today. They're approximately 20 to 25 minutes each, with time for questions and answers at the end of all 3. So if you have questions for any of our speakers, please use the Q&A feature at the bottom of your screen at any time during the presentations. I'll ask those questions during the Q&A session. So I'd like to kick things off by welcoming our first speakers. This first one is Bloom, Many Problems, One Solution, with April Thompson and James Fatui. April Thompson is a senior director for Bloom, a branded Class A EQ biosolids product developed by DC Water and marketed by Blue Drop. She oversees all marketing and sales activities for Bloom, whose sales totaled over 65,000 tons in fiscal year 2023. A graduate of the American University and the University of Virginia with an MBA and a master's in international development, April has worked at the nexus of entrepreneurship, agriculture, and the environment, both locally and internationally, in a wide variety of roles and contexts. She's also worked as a freelance writer for nearly 30 years. James Fatui is the Biosolids Operations Manager at DC Water, where he has played a pivotal role in transforming the organization's biosolids management practices over the past 7 years. Under his leadership, DC Water's Bloom product has emerged as a benchmark in the industry for both marketing and revenue generation, setting new standards for biosolids use and sustainability. Additionally, James is at the forefront of DC Water's carbon emissions tracking efforts. He leads initiatives to monitor and manage the organization's carbon footprint, aligning operational practices with broader sustainability objectives and contributing to the reduction of greenhouse gas emissions. Welcome, April and James.
Thank you. Oh, I think James is set to start here.
Oh, I'm sorry. I was on mute. I'm sorry, everybody. Yeah, thanks everyone for having us here today. Yeah, I'm going to start and just go over kind of the basics of our program at DC Water and one of our first case studies, and then April's going to share some additional ones. Yeah, so if you're not familiar with DC Water, our wastewater goes to one primary treatment plant at Blue Plains, which has a design capacity of about 370 million gallons, but we average about 270, 280 million gallons a day. It's a advanced water reclamation facility, so we have nutrient removal, and our service population is about 2.2 million from DC, parts of Maryland, and parts of Virginia. Majority of that wastewater is domestic, so we have very little industrial input, which is a good thing for the biosolid. It means that we've got very low levels of metals and other industrial contaminants. So it makes it not hard to meet those EPA and state level requirements for Class A EQ products. So about 10 years ago, we upgraded our old Class B lime stabilized system with a Class A THP thermal hydrolysis plus digestion. And at the time, we were making about 1,100 wet tons per day of Class B material. And we had gone with this upgrade both in terms of reducing our volume of production, but also making a quality product. And so when we were thinking about this, a lot of the steps of this process were like, how do we make the nicest biosolid that we can potentially market? So, great part about THP is you get a very homogenized material in the digesters, and then we've got belt filter presses, which makes a kind of a nice, much more granular material coming off the conveyors that we then send into trucks. So we commissioned that at the end of 2014, and then got our state permits in 2016. So here's kind of the process diagram. So again, we had our line system and dewatering for Class B. We switched over to having our primary and secondary sludge going into sort of pre-screening, pre-canby. There's a centrifuge which takes it up to about 16% solids. Then you go to THP for about 30 minutes at 150 C. We generally run about 160 to get that time temperature curve, and then you go in the digesters. Design SRTs about 22 days. We ran it as low as 15 and still see like pretty good VSR. Again, and then the biogas goes to CHP. We have a return stream of steam that heats Canby. We recover that heat to heat the whole system. We generate about 8 megawatts of power a year from CHP, and then we probably produce about 150,000 wet tons of Class A biosolids. And when we first started and we got our state permits, we were pretty excited. We sold about a couple of truckloads, but that has rapidly expanded, especially under Blue Drop and April's leadership. Fiscal year 23, we sold 65,000 wet tons of biosolids. So again, that's biosolids where people are paying us money for them. So, which I think we could all agree is a sale. And in addition to those great targets that we met, we really cut our greenhouse gas emissions quite substantially. And this project was discretionary, and the whole goal of it was actually to pay itself back. And we're still on target to actually pay back the capital, about 450 million, with both the revenue generation and savings from the biosolid material going from 1,100 to 450 wet tons a day, and also the energy generation and tier 1 renewable credits. So it's been a really good success story. So what is the material that we actually make? Here's a picture of our fresh bloom, or the cake product. This is dewatered at our belt filter presses to 30% solids. and it's a nice material. It's a little bit sticky, but it's relatively granular, and very low odor, which I think is the biggest thing that's been enabled our marketing program. Before when we were doing our Class B program, we would get dozens of odor complaints a year, and we had field inspectors that go out and use the nasalometers or the nasal rangers. Whereas now with this Class A product, we essentially have no odor complaints. So that is a big transformation that enables us to market it. There is still a bit of ammonia, so farmers are, they love it. They're like, this is the nicest biosolid we've seen. Homeowners can be a little trickier, so that's where we make blended products, which again are a little more granulated. So we mix the bloom with wood fines, hardwood fines, which again makes it a little bit easier to spread, cuts down on the odor. Uh, and also, it provides a little bit of buffering for some of the nutrients. So it's a really good amendment, comparable to say a a compost, a nutrified compost, and that's the majority of what our end users you buy it for. There's a really popular compost leaf grow in our region, and we're often sort of competing with customers and getting a lot of customers from folks who can't get leaf grow because the production out here. There's a lot of demand for organic amendments, not necessarily sufficient supply. Another blend that we make, we essentially mix it with the wood products, but we also add a bit of sand. Again, this is to improve the texture of the soil. We use this specifically for top dressing turf. It's a very popular application. In our region, we have a lot of compacted, heavy clay soils, and so texture is often a challenge. And so this is a product that we get a lot of interest from. And we've done some good studies on showing how it really can improve hydraulic conductivity. So who do we sell to? We sell to a lot of different customers. Okay, there we go. The slide wasn't coming up. Yeah, so we've got about 500 different customers. A lot of our cake is bought by farmers, but we do have construction companies that buy it. We have soil blenders who are making those other registered blended materials. We've got nurseries. We've used it in wetland restoration. In DC, there's a lot of school gardens that have taken advantage of it. They've applied it on the National Mall. So there's a lot of applications where organic amendments and nutrients have a place. What I'm going to talk about today actually is golf courses. And this was one that, when we initially showed folks our cake product, the golf courses were not super psyched about it because it's a little granular, a little sticky, and they're like, this will just be too visible on our fairways and greens. But we've been able to make our blends such that it's been a lot more attractive for those golf courses. So the particular case study I'm going to talk about today is at Fort Belvoir. So this is down in Virginia, and they had a bunch of holes that were suffering from just poor maintenance over the years and really, really compacted soils. You can see here, just really, really poor quality soil, not getting the kind of growth that they would want to see from just a basic fertilizer application. And so they were looking at, for about 2 or 3 of these holes, of complete soil replacement. And that their estimate was quite significant. So they were estimating about $500,000 to fully rip up the soil, put new ones in, grade it, get topsoil, and then plant and seed. And so that was quite a hard cost for their limited landscaping budget. Thankfully, they came across us from a consultant that we had worked with, who works with a lot of golf courses and recommended looking at bloom. And so what we ended up doing, we sent them a couple of loads of our sand blend, again, for that sort of texture benefits. And it was fairly simple what they did. They took a couple of loads and, specifically in those really poor quality spots, they did is they ran an aerator over it, broke up the soil, spread it down, ran it over again so they could get a little bit of incorporation a few inches down in the ground. And I spoke to the site foreman a few days back, and he was like, it really didn't take that much time to sort of break up the soil, apply the material, and then sort of plant and seed afterwards. So really only a couple of days of work, and the amount of product they bought, 1 or 200 yards, wasn't more than a few $1,000s. So again, quite a large cost savings relative to what they were looking at. Here's them watering it. Again, you can see, I think this is in winter. So, they're just, yeah, they got a challenging site that they're working on. But yeah, thoroughly watering it. But the results were very impressive. So these are photos of those holes in the spring and summer. And so, based on the results they saw from what they did, I guess, they're usually golf courses are usually doing chemical fertilizer application. Um, and so organic amendment incorporation isn't necessarily in their wheelhouse. So, the biosolid really kind of filled a gap here, and was able to give them some really, really nice results. Uh, yeah, for relatively little. And I think we often see that out in our region is compacted soils, and the idea of sort of stripping it or tilling your soil completely to repair it is a challenge. And so you're looking for organic amendments, you're looking for things that can improve that texture. And that's where our product has seen some really nice success. One of the things that the golf consulting mentioned was, on some of the greens that they had redone, he saw a much better root development relative to what you typically see in these areas. And his hypothesis, which I think bears some basis, is that compared to standard chemical applications, which a golf course would do pretty heavily, you just get a lot less nitrate formation with an organic amendment, which can inhibit that root growth. So that was kind of a nice thing that we saw. So again, we've got quite a few golf courses that are interested in using our product. A lot of them do top dressing, specifically in the rough areas, sometimes the fairways. Greens are a little tougher. This consultant recommended doing a mostly sand, partial bloom recipe, like 97% sand, 3% bloom, which is a little bit tough for us to make and justify. But yeah, we saw some really great results. And so, golf was one that, my boss, Chris, really wanted us to break into, because we know it's good for turf. We all know how great Biosolids is for turf. And so we're finally kind of reached that. We're kind of known in our area among golf courses, which has really been, some great work that April and the rest of the Blue Drop team have done. And so, yeah, it's been really great to see some of these successes. And with that, I'm going to pass it off to April to talk about another project.
Thanks, James. So as James mentioned, we have a really diverse set of customers, and as such, we work on a diverse array of projects, which it's one of the things I really love about my work. So I'm going to give a few different cases now. This first one is another turf project, but kind of facing different challenges. Essentially, the contractor here is an earthwork and grading contractor called Urban Zinc, and they have a focus on public sector work, and essentially have carved out a niche for themselves doing this earthwork services for school districts throughout Maryland. They've done work in Anne Arundel County, Baltimore, Montgomery, Howard. But one of the challenges they face with that is the specifications on the topsoil. Um, they um, they have to, not only increase. Actually, James, maybe push that one forward. Yeah. So each county has a different spec. They all have a particular organic matter improvement rate that they're looking for. In this case, the Crofton High School, which was a new built high school in Anne Arundel County, where they needed to improve anywhere from 3 to 5 or 5 to 10% organic matter, depending on the landscape architect. And on top of that, they have a warranty on these projects for a year after placement. While meanwhile, the schools often lacked the funding to basically do the kind of maintenance that normally would be required to keep things looking great. Um, in addition to I think a 95% germination rate. So not only needing to have that really nice green up at the beginning of the project, but continued throughout. And so they found with Bloom kind of the best of all worlds. getting the organic matter percentage up through the high organic matter that bloom contains, but also the nitrogen to get a quick green up, micronutrients to kind of get a really nice dark color to the turf that made everyone happy. So what you're seeing there is just a screenshot from this particular project, what they were required to do. I guess I should back up for a second to say prior to that, they had been using basically leaf grow, which is our local leaf compost. And we're kind of having a few issues there. One was just availability. Leaf grow is in high demand and sometimes can't get everything on the kind of timetable that they needed. And then they also found that when they got a lot of rainfall, sometimes there were like larger chunks of the material that would actually float to the top and choke out seedlings, making it difficult to establish that turf. So all of that brought them to bloom. And actually, coincidentally, I didn't even kind of make this connection until now, James, but M&M Consulting, which is the turfgrass agronomist that was used on the project that James just talked about, is also the preferred turfgrass consultant for this company as well. And so they heard good things about Bloom from a man named Jeff Michael that heads up their turfgrass consulting, and decided to try this out. And Crofton being one of the flagship projects that they use Bloom on, and since then we're pretty much what they use on all of these projects. Kind of their standard operating procedure would be, even before they're doing a bid to do random sampling of the soil so they kind of know what they're working with, to be able to figure out how much to put into the bid. They are stripping that topsoil, combining Bloom the in situ soil with Bloom on site, running tests on that to kind of see if they're going to meet the spec, and then working with that agronomist to kind of button everything up. And if you'll go to next slide, that's just a site of once this has been stripped. This is the Crofton High School site. It's 27 acres, and so they had stripped a total of like 40,000 yards of existing topsoil, having to put back 27,000 yards. So really huge project. There's something like 1,500 yards of bloom used on that. And you'll see in the background there that dark black is bloom, which if we go to the next slide, we can see a little about how they work that in. So essentially, they had to go down 4 inches, pulling that topsoil, tilling the ground, using a rock hound to basically remove any large anything larger than 1 inch. Then they're putting back 2 inches of topsoil, and then a final layer of topsoil that had the bloom incorporated. They are grading that, and then they are either seeding or sodding. So that's kind of their recipe. They also would bucket mix material for areas like the slopes where it's difficult to get the bobcats and things like that. If you go to the next slide. So this is an aerial view of the final project there. You can see at the bottom those two very dark green spots there. That is the high school itself, whereas to the top of the slide you can see like a lighter field there. That's actually a middle school that was adjacent. I believe this was in April, so things were just starting to green up, but you can really see a difference in basically where the bloom had been incorporated. Um, so um, so yeah, if you go to the next slide, I will kind of talk through basically their feedback to us and why they continue to come back for projects like this. Essentially easy to incorporate, um, especially given the kind of equipment they have. Now we have since tried to sell other contractors on this method because it's going to save you a ton of money. Not every site this will work for. A lot of the smaller projects, particularly in the district, they don't necessarily have the space and equipment to be able to do that in situ blending that is going to save so much money and not have to part off existing topsoil. But in their case, they're, working on sites where they can pretty easily do this. Our consistent availability of material, dependable outcomes and stability. Again, that sort of blend of having the organic matter they need to meet spec, along with the slow release nitrogen that they see the green up in the beginning, as well as the kind of longer term results going into the end of their warranty period, which again gives you those fast visual results. And then ultimately, they are a for-profit company. So, I mean, we're talking a huge cost difference to get our fresh material versus something like a leaf compost. So for them, it's really a no-brainer. And we have continued to work with them to this day. All right. So if you go to the next slide, we're gonna pivot to a quick farm case. And when it comes to the fresh bloom, that's really our bread and butter is serving farms. It's probably about, I want to say 80% of our volume does go out to farms. And these are primarily farms in Maryland where we um, you see very little irrigation, and so they're really rainfall dependent. And so a lot of them really struggle in a year like this, where it's kind of been feast or famine in terms of the rainfall. And that's where a product like Bloom can really make a difference. And his case is one where he really saw a difference this year as a result of using Bloom and other organic amendments to basically help get that resilience in his fields. Anyhow, to kind of go back to the start with this farmer, his name is Lauren. Actually, I think there's no E on the end there. That's my fault. Lauren Carty. And he has been farming ground in Washington and Frederick counties for the better part of 40 years, and has about 600 acres under cultivation. We could go back one more slide to that first one on. There we go. So he rents all of his ground and essentially for the longest time really had trouble breaking out of what I call like a yield rut, just using traditional commercial fertilizers, but was a little bit reluctant to really invest more into this land since he was renting it and at any time it could be kind of taken away from him. But he said, the last, I don't know, 5, 6 years, he finally just said, you know what? They take it from me, they take it from me, but I'm gonna make some long-term investments in the soil. And he started with chicken litter 4 years ago and really started to see an improvement in his yields. And this year decided to incorporate Bloom as well. Originally thinking that he was going to get phosphorus, that's not really plain available actually, but in our product, but immediately started to see the other benefits with our organic matter content, improvement of CEC rates, and this year essentially used Bloom on all but 40 acres, using, I think, 2 tons of chicken litter in the fall. And then he used 20 tons of Bloom on his sorghum, which is what you see here, and 10 tons on the soybeans. And it's interesting in the past, in the prior case we just talked about, they talked about that visual results, and Lauren had the same thing to say in terms of just what he saw, particularly in the real heat of summer. You know, while some of the other, some of his neighbors' crops were starting to dry out and brown, he really saw resilience in his fields. The better color, bigger heads on the sorghum, and just overall healthier looking product. And bottom line is the yields, and he says he's expecting something like 150 a bushel this year and has never broken 100. So that's kind of saying a lot in a really bad weather year. Go to the next slide. And that's his soybeans there as well. Um, he was saying, like, I mean, the leaves on some of these are so large, he could just like even hold a single leaf with both of his hands. And I just included this quote here because, I think increasingly we're talking to farmers who really get this. Like, this isn't, you know, you you're not going to get like a quick hit and, one and done with this. You have to keep working the land, improving the soil, and making that sort of long-term investment that is going to get you through difficult years like this. With that, I'm going to thank you for your time, and I think look forward to questions later.
Thank you, April and James. And as a reminder, you're welcome to post questions using the Q&A feature at the bottom of your screen as you start to think of things between and throughout the presentations. And again, we'll answer them all at the end. And so thank you. Our next presentation is Harnessing Biosolids to Reclaim Mine Lands, Case Studies from Appalachia, with Sam Liebel and Ryan Terwinski. So Sam Liebel is a director of communications at Denali, the nation's leading full-service recycler of organics. Based in Colorado, he works closely with operations and compliance teams across the U.S. to communicate Denali's role in the circular economy. A former journalist, Sam holds a master's in environmental management from Western Colorado University. Ryan Terwinski is an area manager with Denali. He manages Biosolids land application operations and compliance, and he also works with farmer partners to maintain Denali's land-based beneficial reuse in Pennsylvania. He received a bachelor's degree in environmental sciences from Bloomsburg University. And prior to joining Denali in 2021, Ryan worked as an agricultural specialist for state and federal agencies in Pennsylvania. Welcome, Sam and Ryan.
Thank you for having us.
Okay.
Looks good on my end, Ryan.
Great.
Cool. Well, we can jump in. My name's Sam Liebel. I've actually switched over to the sales team since I saw folks from MABA last, but I still really enjoy telling the story about mine reclamation, and I'm focused specifically on Colorado now, but we're applying the lessons that we've learned in this part of the country in Appalachia to some potential projects out here. So Ryan, you can go ahead and move to the next one.
See if I can. How about that?
There we go. Yeah. So I'd like to get started here by just talking about the scale of this issue. In the eastern part of the country, about half of the coal that has been extracted in the United States over the last 2 centuries has come from Appalachia. And since just the 1970s, 6.5% of this shaded area on the map has been disturbed by mining, 2.5 million acres. So it really is a large thing that we are confronting out here. And fortunately, biosolids provide a pretty effective solution. Right, next one. Coal has seen better days in the United States. You can actually see production ramping up, and then about the year 2000, it plateaus and then falls. In recent years, coal production has bounced back a little bit. A lot of this is because there's just less demand domestically and internationally for U.S. coal. And on our side, what we're seeing in Appalachia is that the really big coal companies, they're not as prevalent as they used to be, but there's a lot of small and mid-size operators still mining coal. And it's with those that we're seeing more opportunities recently. Okay, next one. So the need for reclamation is massive. Current mine permits are about 500,000 acres of land, and of that, the majority has been partially reclaimed, but nonetheless, there is about $6 billion worth of work to do in this region with reclamation, and there's only $2.5 billion in bonds available to do the work. So there's a mismatch between the resources available and the resources that we need. Next one. Fortunately, there are a lot of large cities in this part of the country, and the opportunity to use biosolids from these cities to reclaim mine lands has been called a perfect match before. What we have seen is that there is a much better success rate when you're using biosolids to reclaim mine lands than if you're using conventional methods like chemical fertilizers and lime. And this has been borne out over not just the decades of work that Denali has been involved in it, but that the whole industry has. And so that goes back quite a few years. Next one. I think this is kind of neat here, tallying up how many biosolids or, what quantity of biosolids are available. It's a massive amount. Some of the published research suggests there's between 40 and 80 pounds of biosolids generated per person per year. And if we look at, the two big urban corridors in the eastern US, the Northeast megalopolis that goes from Washington, D.C. to Boston, and also the Piedmont region that goes from Atlanta and into the Carolinas, we're looking at about 4.5 billion pounds of biosolids potentially available. So we'll get into our case studies now. Brian's going to talk about work we've done in Pennsylvania, and then I'll tell you about a very unique place in Tennessee.
Yeah, so I think, as we jump into Pennsylvania, this photo here and some fields highlighted in gray really depict the two different types of coal in Pennsylvania. And some of you on the webinar may be, familiar with this, but in the eastern part of the state, we have our anthracite region. And Denali, although we've been doing reclamation for a better part of 25 years, a lot of our reclamation work has been in the bituminous region in the west. You can just see, the vast amount of coal, which is part of the reason why. But you have a lot more land disturbed when extracting bituminous coal, and so a need for larger quantities and volumes of biosolids, on that disturbed land. So between the anthracite and bituminous, coal, we have about 350,000 acres mined in the state of Pennsylvania, and still over a third of that, lays abandoned. And the reason for that is pre 1977, the Surface Mine Reclamation Act. There wasn't as big of an onus or financial impact put on the reclamation. While it's always been required, reclamation and bonding has always been required as far as the mining process, the stage bond release, and just really just the money forced to be put up by the miners was the reason why they just walked away and did not reclaim these lands. I think also part of that is the conventional reclamation, that was really used most of the time. The success wasn't there. So it was, throwing a lot of money at a problem and not getting a solution. So the three stages of mine land bonding that I talked about, stage one is where the overburden that is stripped during the mining process is replaced. So it's putting the mine back to original grade as much as possible. And Denali doesn't really get involved in that part, but where we find great synergies are in stage two and stage three. So stage two is where you get 25% of your bonds released, and that's establishing cover. So where we really fit well is our lime stabilized biosolids being applied to these mine sites, and then seeding it with our unique mine reclamation mix to that site. It's typically some mix of cool season grasses that gets broadcast across a spread field once we apply our biosolids. And so you can achieve cover with conventional fertilizer and lime, but what you don't get is in stage 3 where they're looking for five years of cover, full vegetation, looking for 70% cover across the site. So the nutrients in the lime stabilized biosolids really starts to build that soil. We get some root mass development there, and that's where we essentially see 100% success rate when using biosolids to reclaim sites in stage 2 and stage 3 of bond release. So Denali operates a bundle of 3 permits. One is our permit to set up our portable processor on active and abandoned mine sites. So we are regulated by waste management through that permit. And so once we identify whether it be an active site or abandoned site, we'll submit a permit application. And then we will, once approved, be able to move into that site and operate our 2 other permits. And those are a PAGO7 and O8 to either make Class A or Class B biosolids. I'd say over the last 2 years or so, we've really stuck to making a Class A biosolid. And the biggest reason of that is for odors. There is, some odor when you're initially introducing lime to a digested cake. And so, the more lime we can add really seem to be, better neighbors to the people who live in the area. And so just to try to be, cautious and mindful of that, we've really stuck to our PAGO7 and make Class A biosolids and use that as reclamation for the past couple of years. And I mentioned the 2 bureaus, but so we're regulated by water quality with our PAGO7 and O8. We're regulated by waste management with our portable processing permit. And then when we're working on an active site, we have to amend the active mine permit regulated by District of Mining to include biosolids as a reclamation option. And I just have listed here the 6, different PADEP regions. Again, some may be familiar, but it's hard to, gain some continuity when the state is so broken up and regionalized. You have some regions we found who are, champions of biosolids and really likes, what it's been able to do to reclaim, these thousands of acres of mine sites. And then there's other regions that have been burned by past projects and public perception. And so, we don't get to decide where the mine, land is. Obviously, we see a big area in Western Pennsylvania, but just sort of hard to gain some continuity and stack, successful projects with different regions and, constant turnover. This photo, this is really shows our equipment. This is, everything you'd see if you'd come out to, one of our reclamation sites. So I'm not sure if you can see my cursor, but trucks will bring material to the site, and we'll use a front end loader to load biosolids in the green hopper there. And then those biosolids will then be augered where it meets the lime coming out of the horizontal lime silo in the background. There's some corrugated pipe that drops that down into the mixer box, and the biosolids are introduced with lime at a very high rate of speed, augered out and onto a conveyor where batches. So we'll make batches depending on how much incoming material we receive in a day. And then we'll, start doing our daily testing. So we test for time and temperature. So we're looking for 70 degrees C, 30 minutes or longer. And then we're looking at a pH of 12 for 2 hours, and then 11.5 for the final 22. Our application rates on the active mine site is 60 dry tons per acre at a reclamation rate. And that is determined based on the percent solids of the final stabilized product. So once everything meets and the material is stabilized and ready for reclamation, we sort of get back to your traditional farming practices to do the reclamation work. So the photo on the left, you'll see that, similar processing unit, front end loader, lime silo, auger processor that is all pug mill processor that's all on a trailer right here. And then sort of in the foreground a little bit more, this is a recently reclaimed site. You see the, vegetation, really appearing here, and your typical tractor and disc for incorporation. We use a rear discharge manure spreader to apply the biosolids because we are applying it at such a heavy rate. And then we'll run over it multiple times, with a disc and other type of incorporation implements to try to build that soil profile back up. Because what we're trying to do is there is no topsoil. You can see, the black coal loading area in the foreground there. So we're really trying to build topsoil. And so that's why, the 60 dry tons per acre is really important. And you'll see on the back here, we have a broadcast seeder that has our cool season grass mix. And then once again, going over with a disc for contact for seed growth. I think these, photos here speak for themselves, but this is, sites before, biosolid reclamation. So maybe a little bit of, voluntary vegetation, but just rock and gravel and nothing that resembles topsoil. And then again, here on the right, here's a site that has been, we hit stage 1 of bond release where the overburden is put back. And this site too is ready again for some biosolid reclamation. Some of these photos are really show, hopefully on the left side, you can see that, dark organic, matter there and just the dense vegetation. And this is 1 year after reclamation, after we applied the material and we went through our incorporation and seeding. And this is our team here in the middle doing their soil sampling, which we're required to do for soil fertility for 2 years post reclamation. I mean, vegetation, just up to their knees. And again, on the right, just, lush, dense vegetation, which is what we see, in every biosolid reclamation site we're working on. I think here on the right, this photo really does show the difference between conventional and biosolid reclamation. There's a permit boundary here. And so on the left side, they were trying to do some sort of conventional reclamation with either, liquid or granular commercial fertilizer and some lime, and just no success. And then, or I said on the right, sorry, on the left. And then on the right, you see, dense vegetation here. And this is biosolid reclamation with our lime stabilized material and our cool season grass mix. And unfortunately, we weren't, able to do this side, just how sort of the permit boundary lays, but just, provided a great photo for us. And down here in this table, we wanted to just, see what the soil was, what soil fertility was like pre-reclamation. See very acidic pH and very low nutrients. And then again on the right, this is an average of our 2-year post-reclamation sampling. A pH is, more balanced, a little high, and then, really good, nutrients as a medium for plant growth, for the future. And soil health benefits, I mean, I think it goes without saying, but erosion control, biosolid reclamation essentially eliminates, rill and gully erosion. We're getting some moisture retention, definitely root mass development and water infiltration. We haven't seen any studies to show the reduction in acid mine drainage, but if you can imagine, this field on the right here, really good infiltration, really good root mass development and moisture retention here. Just some more photos of conventional reclamation. This is a site, edge of the permit boundary, close to a town. So we weren't able to do biosolid reclamation here. You can see drill marks where they tried to go through and seed grass and apply conventional fertilizer. And then again on the left, you see just that rocky. It's hard to call it soil, rocky overburden, and just you get a little bit of vegetation because you're putting, high levels of, commercial fertilizer down, but nothing for the long term, success of that habitat or ecosystem. Some of my favorite photos. I don't. Some of you may know him. This is. I'll sell him out. This is Stefan Weaver here walking through a previously, um, recently reclaimed field and just walking through dense vegetation, grabbing, some good photos that probably ended up on this presentation. Then again, this is on top of a rock pile, a 50, 60 acre reclamation site, surrounded. A lot of these old mine sites, this is on a private land. There's a lot of hunting leases around there, and we hear often from people who are members from the hunting club how, they love hunting over these properties because it's pretty much the only time that there's vegetation all year round, and the turkeys and the deer and the duck and the geese, um, they're here, they're feeding here, they're raising their youngs here because this is, starting to become, a part of the ecosystem again. I think this photo, probably one of my favorites. Again, this is a reclamation site we did on state game lands, and the state has put a lot of money and effort into reintroducing elk into other parts of Pennsylvania, and largely unsuccessful. But what we saw was, again, vegetation, feed all year round, and a herd of 100 to 200 elk grazing our reclamation site when we're out, um, you know, checking on it. Just really, really cool to see the elk, voluntarily come here to graze. We're able to. We like to talk about, turning a moonscape to a meadow, and we really see that. I think biosolid reclamation on mine sites is one of the greatest end uses for biosolids. It's so visual, and really we see it in a 1 to 2 year turnaround. Um, in our 25 plus year history, we've reclaimed, roughly 3,000 acres of impacted mine lands, applied about 500,000 tons of lime stabilized biosolids across state game lands, state forest lands, and private lands. And I think this is just another photo of what we call a moonscape, and turn it back into a meadow where wildlife thrives. Some things I think we're really good at: the lime stabilization, the portable processing, stabilizing the biosolids, and then applying it and seeding or cool seeding grass. But some of the opportunities that maybe we'll look at and hopefully look at in the future is carbon sequestration. That is a byproduct of our reclamation. I mean, certainly the habitat improvement that we talked about, all the wildlife that you see flourishing and then flocking back to those sites. And then if it's not hunting, maybe it's sightseeing or bird watching, or is taking a stroll and enjoying what used to be a coal mining area to, part of the ecosystem. So with that, I jumped ahead, but I'll turn it back to Sam to talk about our case study down in Tennessee.
Yeah. So I'm going to tell you about the Copper Basin of Tennessee. And we usually think of mining in Appalachia as, focusing on coal, but this was actually a copper mining site that then transitioned also into zinc production and also sulfuric acid production later on. This photo shows the problem that we're still dealing with in this part of the country. That's the Ocoee River flowing past the smelting site. You can see it's changing colors there, just being really impacted. And the landscape you can see is bare, and I'll talk a bit more about why that's the case. Next one. So for a long time, astronauts on the International Space Station could look down and easily find the Copper Basin. It's a denuded area in an otherwise lush part of the US. And the reason that the area lost its trees and really all of its vegetation to speak of is because of the process that they used to smelt the ore called heap roasting. They would get chunks of the ore together, put them up in a pile, and also stack that with timber. So they were cutting the trees down in the area for firewood. to do this smelting process. Then once they set the heaps on fire, that was releasing a lot of sulfur into the air, which would come back down as acid rain and inhibit new vegetation from getting started. So the area turned into eroded mess. Next one. So this is what the area looked like in about the middle of the last century. The Tennessee Valley Authority built a series of dams in this area, and they were seeing upwards of 2 inches of topsoil being washed off of the landscape in this very large area. So a huge amount of sediment ended up costing the Tennessee Valley Authority a lot of money, needing to dredge those reservoirs and also repair the dams because of the sediment flows. Next one. Water quality has been severely impacted here. Should come as no surprise based on what I've already told you and already shown you here. States suing each other, the US EPA getting involved. This area would become a Superfund alternative site. And there's a shot of the sulfuric acid plant that was built on the location where Denali has been doing its biosolids application. Next one. So for decades, reclamation in some form has been going on there. It's been a place where scientists have learned a lot of lessons about how to establish trees and rebuild topsoil that's been applied at other mining areas across the US. And if you drive through the area today, it looks like this. It's green. You wouldn't know maybe that there was such a big mining impact. And the river has been cleaned up to the extent that it is now one of the top whitewater destinations in the Southeast US. It even hosted whitewater events from the Atlanta Olympics in '96. So I'll also say that the towns there have transitioned from being, mining communities to now tourism is the main thing there. So people are very proud of the mining past, but everyone's on board with encouraging more tourism in this area. That's the new industry. Next one. One of the very unique things about this site is that there are actually no waters of the state that we need to keep in mind with our operations there. There's 2 main creeks that go through the site. One, you can see in this photo, it just terminates and then is piped into this treatment plant there to drop metals out before it gets discharged to the Ocoee River. The other is diverted around the areas really impacted by mining with a giant plastic pipe. So we in our permitting have, been able to work with the state of Tennessee and the EPA on doing some fairly heavy applications of biosolids, in part because we have this unique water situation. Next one. So this is what our biosolids look like after we have treated them with quicklime on site using a very similar process to the one that Ryan described in Pennsylvania. And we got started doing biosolids reclamation at this location because the current property owner tried conventional reclamation. He spent hundreds of thousands of dollars and had very little to show with it. So the US EPA and the state pointed him in our direction and said, why don't you try biosolids with Denali? So next one. So this is what it looks like. Biosolids, being delivered, moved around the site using trucks, and then we're using, side spreaders to move the biosolids. One thing that's been great about using biosolids on the site is that they're sticky. We can fling them up on a hill and they're going to stay place. We can then seed grass over that. It'll also stick to the biosolids. So it's not just falling down the slope like lime and chemical fertilizer would if we were doing it the conventional approach. Next one. On the right, you can see the kind of results that conventional reclamation were getting. Grass was getting an inch or 2 tall, but as soon as the root, went deeper into the ground, it was encountering really acidic, metal-laden soil and it was stunting its growth. It was then typically dying. So we just get a little bit of fuzz of green on top. So we're working both on areas that have been attempted to be conventionally reclaimed, like on the right, and we're also working with just kind of raw earth that's got a lot of, metals and acid issues going on, like you see on the left. Next one. And these are the results. It looks like a place you might want to cut a hay crop or put a cow. Lush vegetation is a phrase that Ryan used for Pennsylvania. It's what we're seeing in Tennessee too. Next one. These are some before and after shots. You can see the good impact we've had on fairly steep slopes. I will say that a lot of our success is due to a lot of earthwork going on there to grade these slopes so that they're not just eroding anymore. Next one. This is mud flats. It's an area that was bare for, maybe 100 years, and now it's got green coming back. Next one. Another example of a steep slope and kind of the positive impact we've had there. You can see the terraces that have been put in place to keep erosion under control. Next one, Ryan. And I'm really proud of this one. This is a pond that everyone sees if you're either entering the mine site or if you're just driving along the road into the town of Copper Hill, Tennessee. This pond was orange, lifeless, a nasty thing for decades. It's now a more natural color for water. It's got trout living in it. There's also trout on several other ponds on the mine site, and there's ducks, raising their young there too. So it's made a visually striking, improvement to this site. Next one. I think, besides just the effect that we've had on the land, the effect that we've had on the community is worth talking about here. We have really put a lot of effort into communicating with the local governments there and nearby residents, the work that we're doing, and trying to bring people along with the idea that this is a good thing there. We've changed generators. We've switched from a Class B to a Class A. A lot of that is to manage odor. And the process that we've landed on, applying lime, it releases a lot of ammonia initially, but once that off-gassing takes place, it's a really not very odorous product. And we've seen a lot of success in that way in terms of responding to community feedback and adjusting our processes so we could be successful. So next one. I think we're at an end there. So yeah, Mary, thank you for having us on here, and we'll wrap it up for Denali.
Thank you. Man, I just want to go outside and go for a walk now. But alas, our third presentation, the Capital Region Water Biosolids Journey, 2 decades of overcoming challenges to pursue beneficial use, with Lisa Challenger and Jess Rosenthal. Lisa is the CEO of Material Matters, with over 11 years of experience in marketing, permitting, and managing biosolids and residual matters. She has led master planning projects and biosolids market assessments in over 24 states, with a focus on market opportunities and permitting pathways, and figuring out what to do with the pile. Lisa is a 2012 graduate of Penn State with a BS in Environmental Resource Management. When not at work, she enjoys catching bugs and splashing in the creek with her 2 sons. Jess Rosenthal began his career working as a wastewater operator at the Advanced Wastewater Treatment Facility in Harrisburg, PA in 2004. From there, he progressed through management positions of increasing levels of responsibility, ultimately landing as the Chief Operations Officer, where he currently serves their wastewater and stormwater departments. Jess has participated in the design, construction, management, and commissioning of over $150 million in capital improvement projects for the Harrisburg system. Welcome, Lisa and Jess.
Thank you very much, Julianne. And thank you for having me here. It's a pleasure to be here to talk about one of Capital Region Water's proudest programs, one that's really near and dear to my heart, just because I was here at the inception of it. And it's one that does so much good for our ratepayers and for the surrounding agricultural community. So I'm going to take a couple slides at the top here and introduce our system, who Capital Region Water is, and later on I'll hand it off to Lisa for some details about our self-managed program. But Capital Region Water is a public municipal authority in the capital city of Harrisburg, Pennsylvania. We provide water, wastewater, and stormwater services to Harrisburg and several outlying municipalities. The wastewater population served is approximately 125,000 people. But it's very important to note that of the population that we serve in Harrisburg, about 33% of that population lives below the poverty line, and about 50% of the children in Harrisburg live below the poverty line. So anytime we have an opportunity for any cost saving measures that can offset potential rate increases, like many other old cities in the United States, we have very old and for decades ignored infrastructure here in the city of Harrisburg. So rate increases are expected for decades to come. Anytime we can find any kind of non-rate revenue or cost saving measures, that's always something that's great that can really help offset those rates for that impoverished rate base. Go ahead and flip, Lisa. So a little bit about our facility. You see the picture there. We do have primary and secondary clarification. In 2016, we upgraded to biological nutrient removal facility. We have mesophilic anaerobic digestion. We just recently completed a $15 million digester rehabilitation project for both of our 1.8 million gallon anaerobic digesters. From there, we do water with two 2.5 meter Ashbrook clamp presses, and we produce a Class B biosolids product. We use alternative 1 for fecal coliform testing every 2 months based on the volume that we produce, and we use option 1 and achieve greater than 38% volatile solids reduction. But one thing that really hamstrings us, you might not be able to tell too well from that picture there, but we are landlocked at this site. We're bordered literally by 2 sets of train tracks. We have the Susquehanna River on the left there. We have a factory to the north, and we have a natural gas peaking facility to our south. So not a lot of room on site, and therefore we really don't have a lot of storage site for our storage for our biosolids. In fact, when we clean out our biosolid storage, if we're running as typical, we run an average of 18 hours a day, and we can fill that up in about 2 weeks' time. So it's very important for us to have a variety of different outlets for beneficial use. Go ahead, Lisa. So as I mentioned, we're going to take you guys on our biosolids journey. This is a little timeline of that journey that started in 2007 and really transformed pretty quickly over the following several years into what we have today. Go ahead, Lisa. But first, I'm going to talk about our very first project, another one that's very near and dear to my heart. It was exciting to be a part of, and that is our mine reclamation project, which was our first foray into beneficial use. Dovetails nicely with Sam and Ryan's presentation for sure. So in the early 2000s, we had a landfill cost increase. I'm chuckling inside when I see these numbers now. But landfill cost increases had brought our transportation and tipping costs to $60 a wet ton. We were spending about $750,000 a year at that point. That price has more than doubled. Our landfill cost right now would be about $130 or $135 per wet ton with transportation and tipping. So obviously we wanted, with seeing that cost increase throughout the 2000s, we wanted to look at alternative options that would obviously lower the cost for our ratepayers, but also provide a beneficial use for a product that we knew could really help a lot of sites. So the first one that was presented to us was a mine reclamation project in Likens, Pennsylvania. It was a site owned by the Pennsylvania Game Commission, a company called Meadowbrook Coal Mining Company. They were remining the site for refuse coal. And when they were done with that project, they were required to reclaim that land in order to get their bonding back, as Ryan was discussing in the last presentation. Just some quick stats about Pennsylvania land mining with over 250,000 acres across the state. 45 of our 67 counties have calm banks in Pennsylvania. If you've traveled through the state, I'm sure you've noticed them. We have over 2,400 stream miles that do not meet water quality standards, and obviously a lot of those calm banks and the state's history with coal mining has much to do with that. But there are still active surface mining, and there's remining of calm for that refuse coal, which Pennsylvania has about 2.5 billion tons of refuse coal. And that new refuse coal is burned at several different facilities throughout the state. So project initiation, I remember this being feeling like a very delicate attempt at first, just because there was certainly a lot of suspicion from the rural community that we were going into. But Material Matters did a great job of walking us through that process. We started by contacting public officials and discussing what our project was going to be, what the benefits were going to be of it. We conducted an odor assessment of the product. Luckily, our product actually, even though it's a Class B product, has a very, very minor ammonia odor, but nothing that's especially pungent. We went as far as making presentations to the public, where we, listened and addressed any questions that they had. And we even implemented a voluntary water monitoring program where there were a lot of well sites, or a lot of the residents were using well water at adjacent properties. And we offered to monitor that water, established a baseline before any of the spreading started, continued that monitoring throughout the project and even afterward. So our general permit for biosolids, we received that Class B general permit within 1 month. Again, very low odor. PA Department of Mine office was a lot more difficult to get through. It was about an 18-month process. Again, very difficult to get straight interpretation of rules. It involved, several meetings, probably approaching a dozen. But again, we held a public hearing because the public requested it, and we were happy to stand up there and stand behind our project. We were very civilized in it. We listened to their concerns. We wanted to make sure that they felt comfortable with the project that we were bringing into their community. Here's a before and after picture. I wish I had as many as the last presentation did. But again, something that we're very, very proud of. We had 17,000 wet tons that were applied on this site. And that's over a year's worth of production from our facility. So that was a great cost savings to Capital Region Water. I still go back to Google Earth every now and then and go back to this site. Unfortunately, this was our one and only mine reclamation site, but it really is cool to see the before and after pictures of it. So cost analysis, no brainer, really. We were at $55 to $60 per ton on landfill when you factored in transportation and disposal. Whereas with the mine reclamation site, we were at $17. With almost 17,000 tons, it was a savings over that 2-year period of $641,000. Again, that's in 2007 dollars. I can tell you that savings would be well more than doubled just for that one project alone. We'd probably be looking at something closer to $1.5 million. So from here, I'm going to turn it over to Lisa, who's going to talk about their role in our self-managed program. Go ahead, Lisa.
Sure. Thanks, Jess. So I think Jess has really relayed how Capital Region Water got the taste of beneficial use through that mine reclamation program. And really from that point forward, there was the question of now what's next. And so there was this decision of we have this wonderful, successful beneficial use program. Now what can we do to keep it managing moving forward? And so where there was this transition to the agricultural land application program, it's more of the conventional program that most people here would be familiar with from the biosolids standpoint. So at that point back in the late 2000s, there was this question or this decision of how are we going to implement this biosolids land application program through a third-party contractor or a self-managed program. So one thing I do want to point out is there's a number of different facets of a biosolids beneficial use program that need to be managed when deciding to make the decision to go forward with a beneficial use program. And at this point here in 2024, there has been a transition by many utilities due to staffing challenges, not close proximity to agricultural land application sites, to go forward with this, what we call the third-party contractor managed program. So that's where we're really bundling a lot of these services, the transportation, the permitting, the actual land application itself under a single contract operated by a third-party contractor, such as Denali, who just presented. One other alternative option, which a lot of utilities continue to do, is this self-managed program. And as you see, the different options I have here, the different components of the project can either be managed internally in this self-managed program, so where the utility can own and operate the trucks, can do the beneficial use permitting, can actually operate the tractors or spreading. Or there's this alternative option where we can contract bits and pieces of the program out, where there might be a bid spec for transportation, or maybe we're working with farmers directly for them to do the spreading. And that's really the option that we helped Capital Region Water to develop, is this self-managed program where Capital Region Water isn't necessarily doing all of the bits and pieces, but we're kind of piecemealing this program together to have potentially a lower cost, but also to allow Capital Region Water to have a bigger hand in the game. And one thing I do want to note, this self-managed program idea is certainly not a novel one. Back in the early 70s, when the Clean Water Act came to fruition, there was a lot of federal money, a lot of federal dollars that were granted to utilities for them to purchase their spreading equipment and transportation equipment. And so that's really where this self-managed program idea came to be. And so with Capital Region Water, we went to go to this slightly different non-conventional route where we're piecemealing under multiple contracts these various services. So the various pieces we have for the land application program that I'm just going to touch on here are the qualifying or identifying new land application sites, how we're going to get at the transportation, managing the data that's required for compliance and annual reporting, and then that ongoing coordination of moving that pile once every 2 to 3 weeks. So on the outset of the program, there was a number of new farms that were identified for Capital Region Water. And as luck may have it, there was some existing relationships of farms that had been used for other programs. So they were brought into the Capital Region Water program. There's a couple other farm relationships that were developed. And so in Pennsylvania, it's really identifying those farms, getting the landowner's consent that, yep, they're agreeable to it, and then doing that field review where you can see in the map here, identifying those setback areas to wells, waters, streams, any areas where there might be saturated soils. And then in Pennsylvania, for those who aren't aware, land application sites are actually not permitted in Pennsylvania. They're what's called qualified. So we're approving or we're noting that this site is suitable for biosolids, and that's through a 30-day notice. So in which all of the information is gathered, it's submitted to the department, and after 30 days, if there's nothing that's flagged, that site can then be used for those specified biosolids. The second component here is, I mentioned the transportation. Capital Region Water did not have it in their staffing or budget to actually own and operate those trucks. So really what was completed was this alternative method where we're just bidding out transportation as a service. So a bid spec was developed, and I think what's a little bit unique here is that there was zones that were defined in this bid spec. So any of those farms or beneficial use or alternative sites that are within the less than 20 miles, that's that lowest cost option, followed by the zone B, which is the 20 to 49 miles. And then there's this option to go all the way out to 80 miles. And really the benefit of having this is there's this focus to try and get those sites that are closer, but also allows Capital Region Water to realize the savings for whenever sites that are closer are used as part of the beneficial use program. The third component, which I think can sometimes be a barrier to entry for this self-managed program, is really the data management side. So for anyone who's worked on managing biosolids data, we need to be, for a Class B biosolids program, talking about what are those nutrient needs for the crops, and there's some mineralization of nitrogen that can take quite a robust Excel spreadsheet to track. And also for under the Class B permit in Pennsylvania, we're required to track the cumulative pollutant loading rate. Again, spreadsheets are great and they work, but there is this potential for error. So Material Matters has developed a system, Material Manager. It's an access database system that had been established prior to the start of Capital Region Water's program, but it was really a perfect fit of this opportunity to have a consolidated set of information that could really spit out direct reporting that is now in the process of being transitioned to the 21st century in more of a cloud-based platform to allow for additional options that are a little bit limiting in the access platform. And then I think the final component, which is perhaps the most important part of Capital Region Water's beneficial use program, or any beneficial use program for that matter, is the ongoing farm relationship. Noted that there is limited on-site storage for Capital Region Water, and there's this continued open communication between CRW, the transporters, and the farmers. And our team is constantly going out and visiting with our farmers, developing those relationships. We've had a couple farmers. There's one pictured here that's really drunk the biosolids Kool-Aid, if you must, that they actually went in on their own dime, invested in a biosolids storage facility on their farm because they saw the opportunity to improve the biosolids quality, allow for some additional staging, and allow the product to dry out a little bit. So this is the picture of the first load going into the storage earlier this summer for the grand opening of that particular facility. So overall, Capital Region Water's biosolids program has been really, really successful with the farm relationships. But I'd be remiss if I said that it was always rainbows and unicorns. There have been a number of challenges that we've dealt with in managing and supporting with this program. One of them, which we've all seen, which is changes in weather patterns. The wet year of 2018, 2019, some of these dry or wet spells that are a little bit atypical, not necessarily having some of the harder ground or solid frost in the winter has caused some challenges in managing the program. There have been some landowner changes, and really it's at the mercy of whoever is owning the land as to whether or not biosolids may be land applied on those sites. The one big note, Jess mentioned that there was a BNR upgrade in the mid 2010s. For anyone who's not aware, BNR, biological nutrient removal, has a double fold effect. We're increasing the amount of solids on a dry weight basis, but there was also about a 2 to 3% drop in dewatterability. So we saw a 25 to 30% increase in wet tonnage being produced, which made that limited on-site storage even more of a challenge in managing the cards. So really these programs can be very, very successful. But at the end of the day, if we're not staying on our toes and constantly looking for new opportunities, there can be some big challenges, and we can get caught pretty quickly if not being very proactive in finding those new opportunities. So overall, as we're talking about Capital Region Water's program since the early 2000s, so 2007 to 2024, almost 20 years of beneficial use, long-term success, this continued engagement and investment into the program, having the utility members actually involved in what's happening to the biosolids can really pay off. And ultimately, even as Jess was talking about the 2026, 2027 landfill disposal costs, the program continues to be cost effective in this way of having nearly 100% beneficial use and roughly $40 per wet ton average cost in this last calendar year. And with all that to say, again, all of this is continued, constant, proactive effort to allow for continued success.
Thank you, Lisa and Jess. All right, so we had some questions come up in the Q&A panel that I will read through and the answers for those. While I'm doing that, I think there's a question for Sam and Jess and Lisa to answer as well. So our first question for the DC Water Bloom product, what is the cost of this soil per ton? The cake product is $3.50 per yard, and the blends sell between 12 and 24 per yard. The furnished topsoil is from 35 to 50 per cubic yard, and that's the same for many organic amendments. The second question is, what is the average EC salinity of your product? James said around 7 for the cake, 1 to 2 for the blends, but those are
do you
mainly...
want me to talk through the answers here? Or...
Oh, sure. That would be great. Thank you, James.
Yeah. Just on the last one, that was for comparison. Furnished topsoil that someone could buy, is quite expensive. And so, yeah, so we're just undercutting the market on price. So the question about electrical conductivity, it's a challenge in these projects where we're getting spec'd in because of our high ammonia content. You get picked up in those topsoil specs, which normally are pre-nutrient application. And so it's always difficult when you're incorporating it to meet the organic matter spec, which would precede that nutrient step. So, yeah, we generally have to make an argument with each sort of like specking agency about why we should get an exception to their soluble salt levels, either if it's an EC or parts per million. And so, but we've got enough data on like looking at the correlation between ammonia levels and EC dropping to make that argument. Yeah. So there's a question about phosphorus, very natural. It's a big challenge here in Maryland, particularly for us with nutrient management planning. So our phosphorus to nitrogen ratio is about 1 to 1. But our phosphorus is bound as iron phosphate because we add ferric chloride. So it's not chemically available when you apply it. And in a lot of soils, it stays immobilized. And we're actually working with the University of Maryland to sort of prove how long will it stay mobilized. Is that a long-term thing? Because there definitely is part of the P-index and the PMT phosphorus management tool that treats it all as one single phosphorus that's chemically available. Yeah, but it is a challenge for nutrient management planning when farmers are like, we need this amount of N, they have to underapply and they add a starter. I think that was all the questions for me.
Thank you so much. All right. And then the next question, which I think is for Sam, is what kinds of treatment systems does it use to remediate the metal loads?
So I think Sam had to hop off,
Oh,
but
got it.
maybe I could pass that to him, or we can connect outside of here to maybe answer that.
Okay. And then for Capital Region Water, what is your average percent cake? How much has your VSR improved since the digester rehab? Or is there not enough data?
So our cake percentage, we were really hoping when we did our digester rehabilitation project, we actually doubled our detention time. So higher VS reduction that improved substantially. I thought it would improve a little bit more. But typically with that, you get better dewatterability. We didn't see too much of that yet. We were hoping to see a couple percent. We're hovering around 17%, 16.5%, depending on the season. That goes up and down. But the digester rehabilitation was one facet of a biosolids facilities master plan that we actually developed in 2017. It's a staged series of projects. This one was the first, but we are actually under construction right now to build what we're calling our energy recovery improvements project, where we'll be separating out our sludge streams. One thing that we've noticed, the thicker we can get our thickened sludge to our digester, the better our cake solids become. So we're thickening out that waste activated sludge, running it through a gravity belt thickener. Primary solids are in a gravity thickener as well, the existing gravity thickener. But then we'll be running that thickened waste activated sludge through thermal alkali hydrolysis process called the Pondus system, made by Centrisis. So we'll have that lysed sludge being combined with the thickened primary sludge, a thicker product going into our digester. We're hoping to get back over 20%. We were as high as 22 or 23% before BNR. We've tried everything under the sun to get back up to that 20% threshold, and it's just been very, very difficult. But we're hoping the Pondus, there's been a good deal of data that we've seen that the Pondus process, as well as separating those sludge streams and independently thickening them, is going to allow us to get back up there.
Thank you, Jess.
Yep.
And the last question is this Material Matters database limited to specific users? What would be something for public use?
So yeah, so Material Manager is we do license it to specific users. So we use it in-house for the programs that we support in managing. And we also have a number of license holders that any utility who's interested in managing their own data as far as nutrient and pollutant tracking and reporting can pay a license fee for that. As far as something that's available for public use, I am not aware of anything other than, like I said, I think there are some spreadsheet templates, but that's about what I'm aware of that's currently publicly available.
Thank you, Lisa. And the last question, will the speaker's contact info be shared? And so I know we're providing copies of the presentations and a link to the video recording. So I think I saw some contact information on those slide decks. Is that correct, Mary?
Yes, if the speakers are comfortable with their contact information being shared, they can just let me know and I'll include that.
Also, last thing, MABA had a Biosolids Spotlight article on the Capital Region and Material Matters and Bloom product in August and September. You can find it by going to the MABA website, hovering over the word MABA to the drop down that says Biosolids Spotlight articles. So with that, that's all the time we have. Thank you so much for attending. Thank you to our speakers. Like I said, we'll be providing copies of the presentations and a link to the video recording in the coming weeks. Our next webinar will be Tuesday, November 12th on digestion, and we encourage you to check out the information available on our website, M as in Mike, A alpha, biosolids.org. Be on the lookout for emails or feel free to reach out directly to Mary Baker, whose information will be provided in the chat. Thank you so much. Have a great day.
Thank you.